So today we are going to discuss about basic processing unit. So basic processing unit is an important part of any kind of computers. We can say in other words it is a central processing units. Yes. So processing unit which executes the machine language instruction and coordinates the activities of other units in a computer. Machine language is nothing but zeros and ones. Okay. So next one, we to examine. Also, we are going to discuss about how the fetching, decoding, execution instructions are performed in here. So this is called basic processing unit. So some of the fundamental concepts like computer doesn't know about alphabets, so we have to give some instruction in the format of zeros and ones. So any kind of processor can fetch one instruction at a time and performs the operations. Okay. So we have some basic steps to perform the instructions. So first one, always the processor fetch the memory location content into a program counter, means where the program should be started. It will be stored in the program counter. So again, the program counter will be incremented every clock cycle by 4. Okay. So after fetching the instruction, we have two types of phases. So one is instruction fetch phase, another one is instruction execution phase. So in fetch phase, the processor fetch the instruction from the memory and loads the instruction into instruction register. So this phase is called as instruction fetch phase. So instruction after fetching the instruction, we processor performs the next operations but with the help of ALU. So that is called instruction execution phase. That is performing the operation specified in the instruction is now known as instruction execution phase. So generally, any kind of instruction performs all these processes. First one, read the content of a given memory location and load them into processor register. So first, processor read the content from the memory location which is mentioned in the program counter and load them into processor registers R1, R2, R3 kind of registers. Then read data from one or more processor registers. Again, the stored data from the processor register will be moved to ALU to perform some arithmetic and logic operations. Again, after the performing the arithmetic and logic operations, the result will be stored in the processor registers itself. Okay. After storing the results in the processor register, again the result will be sent to memory locations so that users can view the final results of an instruction. So next, hardware components of the process. So we have a more number of blocks in the hardware. So first one, instruction in a register file. So which is nothing but it is a small storage element which is located in the processors, that is R1, R2, R3, R3, R4. All the registers will be in the register file. Then control circuitry which generates some control signals so that further operations can be performed by the processor, like read memory, write memory kind of signals. Next one, instruction register, which is nothing but which stores the instruction which is fetched from the memory. Okay. Next, ALU. It is an heart of any kind of processor. It is an ALU which performs all the arithmetic and logic operations, which will be comes from where the input will be comes from the register file. The output of the ALU will be again stored in the register file. Next one, instruction address register, which is located along with PC, that is program counter, which is the program counter stores the next address location to be fetched. Okay. Next one, processor memory interface. Processor memory interface is nothing but which interfaces the processor and the memory blocks. So we know that generally a processor doesn't contain any inbuilt memory, so that we have to interface additionally our microprocessor or processor. So that is the general blocks of a processor. So next one, instruction execution. So we have a three type of instruction executions. So first one, load instruction. Next one, store instruction. Next one, addition add instruction. So first we are going to discuss about load instruction. So first we are considering as the instruction load R5 comma X of R7. So this is nothing but from right side to left side the data will be loaded. So here the load R5 comma X of R7 is an index addressing mode, means X of the X is nothing but it's some value which is added with the register R7. After adding the register R7 we will get effective address, that is memory address. From the memory address, in the memory address there will be some content or value. That content will be loaded in the R5 register. So this is the process of load R5 comma X of R7. So first step we have to fetch the instruction from the memory. Then we have to increment the program counter. After incrementing the program counter we have to decode the instruction to determine which operation to be performed. Then register R7 will be reader from the in a register file. Then a register file R7 is added with the immediate value X. After adding the value of X, we will get effective address. So in the effective address, there will be some content or data. That data will be loaded in the R5 register. Okay. So these steps will is summarized with the five simple steps. So first one, fetch the instruction and increment the program counter. Next one, decode the instruction and read the content of register R7 in the register file. Next we have to compute the effective address. Next, the read the memory source operand, then load the operand in the destination register R5. So these are the five steps of load instructions. So next one, arithmetic and logic instruction. So we know that arithmetic and logic performs addition, subtraction, then and our operations. So this is totally differs from load instruction. So here we are doing the arithmetic and logic operation doesn't access any memory locations. Also, the source registers the maybe the registers source will be a registers, maybe a immediate operand value. Okay, so we have a example, add R3 comma R5 comma R5. So first step again, if we have to fetch the instruction, and then next we have to increment the program counter. Next we have to decode the instruction. Once decode is completed, we have to read the R5 and R4 and R5 register, which is in the register file. Then we have to compute the sum operation of R4 and R5. So now the R4 value and R5 value is added, and the result is in ALU. Okay. So next one, there is no action because we are not accessing any memory location. So next fifth step, the added some value will be stored in the destination register R3, which is located in the register file here. So the here no memory in access is involved as like as not load instruction. So it is another kind of instruction which computes the effective address for addition operation. So next instruction, store instruction. So the store instruction also has five steps. It is we can say, and easily we can say it is a opposite of load instructions. Okay, so we have an example, store rx of R6 comma X of R8. So the content of R6 will be stored in X plus R8 value, means so we have to add the X value with our R8 register so that we can get the effective address. So after getting the effective address, the result of so the value of R6 will be stored in the effective address. So similarly, we have a five steps. So first we have to fetch the instruction, and we have to increment the counter, then decode the instruction, then we have to read the R6 and R8, then we compute the X plus R8, that is effective address. So store the content of R6 into that effective address. So there is fifth, there is no operation in the store instruction. So generally we have a 5 steps. This 5 steps includes fetch the instruction and increment the program counter, decode the instruction, read the registers from the register file, perform ALU operation, read and write memory data, then write the result in the destination register. So that's all about instruction execution.